What's interesting about gas turbines is you can use them for many different types of applications. Aircraft engines are essentially gas turbines. They have a very high power to weight ratio, and that's what makes them ideal for usage in the airline industry, where weight has to be reduced as much as possible in order that the aircraft can take off. We're not calling it a gas turbine because we are using natural gas to fire the turbine. We're calling it a gas turbine because we're using a fuel. It may be natural gas, it may be a light fuel oil, it may be coal dust, it may be up to about 30 different types of fuel. Typical efficiencies for gas turbines are around 30 to 35%, going all the way up to 40%, maybe slightly higher, for modern gas turbines. If we combine a gas turbine with a steam turbine, we can actually put that efficiency all the way up to 55%, maybe even 60%, but it's the heavy frame design that allows us to reach megawatt capacities in excess of 250 megawatts. The aero-derivative design is mostly used within the aircraft industry, although it is used for power generation applications as well, and it's essentially a streamlined version of the heavy frame design. So we take the air, it's discharged through these two channels, and then we reach our combustion zone. We're going to inject fuel into this space. The fuel is going to be injected here. We ignite the fuel, we get combustion, we get heat, and we use the heat to heat up the air. Because we're using a gas turbine that is housed within this box here, and the steam turbine is housed over here, within one type of power plant, we're essentially using a Brayton cycle and the Rankine cycle together